All right, let's get into it. Today, we're breaking down two ideas that are seriously the bedrock of modern finance, but they can be a little confusing. First, we're going to demystify something called the discount rate. Think of it like a time machine for money. And then we'll get into the surprisingly tricky question of how to actually average your investment returns. So yeah, let's jump right in.
Okay, let's start with a really simple question. Imagine I offer you a choice. You can have $100 right now, this very second, or you can have that same $100 1 year from today. Which one do you take? I'm willing to bet you'd take the money now. But why? That simple choice, right there, gets to the absolute heart of how we think about value in finance.
And the reason you'd grab that cash right away is because of a principle that pretty much runs everything in finance. The timing of when you get paid is just as important as the amount. It's not just about how much money you get, it's about when you get it.
This whole idea has a name, the time value of money, or TVM. A dollar today is way more valuable than a dollar tomorrow. Why? Because you can take that dollar today, invest it, and it can start earning interest for you. It has earning capacity. And that right there is the fundamental reason that $100 today and $100 a year from now are just not the same thing.
So if we know that money in the future is worth less than money today, how do we figure out exactly how much less? Well, we need some kind of tool, right? A way to bridge that gap between future value and present value. You can kind of think of it as a time travel machine for money. And in the world of finance, that machine is called the discount rate.
What's really cool is how finance pros think about this rate. They look at it through three different but totally connected lenses. First up, it's a required rate of return. That's the bare minimum profit you'll accept for taking on the risk of an investment. Second, it's the discount rate. That's the actual tool we use in the calculation, our time travel device. And third, it's an opportunity cost. It represents the return you're giving up on the next best thing you could have done with your money. They're all just different ways of looking at the same core idea.
And this brings us right to the fundamental rule of investing. Risk and return are two sides of the same coin. The riskier an investment is, the higher the return you're going to demand for taking that risk. It just makes sense, right? And a higher required return means you have to use a higher discount rate. So a risky tech startup, high discount rate. A super stable, established company, much lower discount rate. So how do we actually calculate this thing? Okay, I know this formula looks a little scary, but trust me, it's actually pretty simple once you break it down. It basically lets us figure out the rate of return just by knowing where an investment started, where it ended up, and how long it took to get there. Let's walk through an example. Let's say your portfolio grew from a present value of $10,000 to a future value of $16,000, and it took 4 years. Okay, first, you divide the end value by the start value to see how much it grew in total. Then, you raise that number to the power of 1 divided by the number of years. That's how we annualize it. And finally, just subtract 1 to get the rate as a decimal.
And there it is, 12.47%. That's your discount rate. In this case, it's also your compound annual rate of return. It's the exact steady rate that would have turned your initial 10 grand into 16 grand over those 4 years. Nailing this calculation is absolutely essential for understanding how any investment is performed.
Okay, so now that we're clear on how to calculate a rate of return for a single period, let's build on that. What happens when you have a bunch of different returns over several years? How do you figure out your average performance? This gets really tricky when returns are bouncing all over the place, which, let's be honest, they almost always are in the real world.
So let's try another question. Say your investment loses 10% in year 1, but then it rockets up by 30% in year 2. Now, if you do the simple average, you get 10%. But did your money actually grow by an average of 10% per year? The answer is a hard no. And that's the problem of volatility.
To get to the real answer, we need to talk about two different kinds of averages, the arithmetic mean and the geometric mean. The absolute key thing to remember is that these are two different tools for two totally different jobs. And if you use the wrong one, you're going to get a very misleading answer. First up is the arithmetic mean. This is the one we all know. It's the average you learned back in grade school. You just add up all the returns and divide by how many there are. Simple as that. Now, the geometric mean, this is a different beast entirely. It's built specifically to handle compound returns over time. It answers a really important question. What was the single, steady, annual return that would have gotten me to the exact same final result? It's all about the effect of compounding. This slide really lays out the difference perfectly. The arithmetic mean is great for answering the question, based on the past, what's a reasonable guess for my return in any 1 year in the future?
But the geometric mean tells you what your investment actually did, what it grew by on average each year over the entire time period you're looking at. They answer two completely different questions.
Let's look at a real-world example. You've got these returns over 3 years. They're all over the place. Now, the simple arithmetic average says you made 7.68% per year. But the geometric mean, which shows the actual compounded growth of your money, is all the way down at 6.82%. That might not sound like a huge difference, but over the long run, a gap like that is massive.
And that's not a fluke. It leads us to what is basically an iron law in finance. Unless your returns are exactly the same every single year, which, never happens, the geometric mean will always be lower than the arithmetic mean. And the more volatile the returns, the bigger that gap is going to be. This means the geometric mean gives you a much more realistic and, frankly, more honest picture of how an investment has actually done.
So why are we digging into this so much? Well, because choosing the wrong average can give you a dangerously wrong idea about performance. It can make a really volatile investment look way more successful than it actually was, and that could lead you to make some pretty bad decisions with your money.
So here's the big takeaway, the simple rule of thumb. If you're trying to forecast what might happen next year, sure, the arithmetic mean can be a useful starting point. But if you want to know what has happened to your money, if you want to evaluate performance over the last 5, 10, or 20 years, you have to use the geometric mean. That's the only true measure of your compound annual growth.
And I'll just leave you with this final thought. The next time you see a fund manager or an ad for an investment that's bragging about its average returns over the last decade, you'll now know to ask a very important question, because you understand that how you average makes all the difference in the world.